Hello guys, we are from Good Sis from Section 5 who take the course SEEE 3533 Communication Principles. In this video, we will sharing about some information and knowledge that needed in order to complete for the mission 4 in a recent task. Our group consists of 4 members, which is Siang, Ainaa, Taufan, and me, Li Hung. For the topics that we will discuss in this video, including the amplitude modulation and demodulation, angle modulations, and also radio digital modulations. And now, I will discuss and sharing some information about the amplitude modulation and demodulation. For the modulation, it used to impress the information on the carrier wave, which is used to carry the information to another location or its receiver. The modulation is the process of shifting the frequency of original information signal from the low frequency range to higher frequency range using the carrier signal. And for the demodulations is the process to demodulate the modulated signal in order to get the original signal they want to present by the senders. The demodulation is the process by which the original information bearing signal, the modulation is the extracted from the incoming overall received signal. As an example of amplitude modulation, we can see from the top left diagram is a message signal they want present by the sender, and equation is equal to EM cos omega nt, and the top right is the diagram of carrier signal, which in the equation of EC cos omega ct. And these two signals will go through the amplitude modulation modulator and come out with the modulator signal, which equation equal to EC plus EN cos omega nt with the cos omega ct. For the amplitude demodulations, we can see the input is from amplitude modulator wave will go to the rectifier in order to remove the negative part of the signal, and it will be the input for the envelope detector or square law detector, and finally the output will be the original message signal. And for the information, the envelope detector and also the square law detector only available for the DSBFC, which is known as the double sideband full carrier. Next, the amplitude shift keying ASK is a form of amplitude modulation that represents the digital data as variations in the amplitude form of a carrier wave. The digital signal is used to switch the carrier amplitude in low or high, and besides that, it's also known as the OOF, which on-off keying, and ICW, which interrupter continuous wave. The string or pulse from digital signal will change the amplitude or carrier signal in this ASK. This is the example of ASK, and we can see the input binary sequence. Digital forms is the output for the ASK, and after it goes through the ASK amplitude shift keying, it will come out with the modulator output wave as the below signal. This is all from the amplitude modulation and demodulation part. Then our group mate will continue with the angle modulations. Thank you.
Greetings everyone. After we study about amplitude modulation signal, now we proceed to the next topic is about angle modulation signal. Angle modulation is the process which the frequency or the phase of the carriers varies according to the message signal. So in angle modulation is divided into two subtopics. First one is frequency modulation and the second one is phase modulation. The difference is for the frequency modulation, the process of the varying the frequency of the carrier signal linearly with the message signal, and for the phase, the process will be varying of the pace of the carrier signal. And this is the sample of the input signal that not have been modulated, and this is also the sample of the carrier signal. For frequency modulation, the change of the frequency or the cycle speed of the waveform in response incoming signal. So this is the sample of the frequency modulation signal that has been modulated. And for the pace modulation, the change of pace denotes a change in the value of the signal from 0 to 1. A continuous wave retains the same value. To solving the frequency modulation, we must know about the frequency shift keying or FSK. In FSK, the digital information is transmitted through the discrete frequency change of a carrier signal. With this scene, the 1 is called the mark frequency and the 0 is called space frequency. So, I give you an example. This is for the 1 or the high data, and the 1 is for the low data. The 1 is for the mark frequency. As you can see, this is the modulated signal and has been modulated in the frequency. It's called mark frequency. And for the 0 or the low data, it's called space frequency. And for solving the pace modulation, we also must know about pace shift keying or PSK. In pace modulation, a change in pace denotes a change in the value of the signal from 0 to 1. A continuous wave retains the same value. For the input binary, you can see this is the sample of 1, 0, and 1. And for the BPSK or passive key modulated output wave, the change of the value of the signal will be marked as a 0. So as you can see, if this is the value is changed to 0, the input binary is also become 0. And if the continuous wave is the same value, the input binary will be 1 or high. I think that's all from me. Then maybe we can proceed to the next topic.
Greetings to all of you. So now we'll proceed to radio digital modulation, RDM. Basically, the three techniques that we learned earlier, which are ASK, FSK, and PSK, can be categorized under RDM. By the way, shift keying means breaking a circuit using a key to shift current value from 0 to 1. We will observe it in a more detailed way later on. Actually, RDM is quite the same as analog modulation, as the modulating signal of both methods will be varied in terms of amplitude, frequency, and also phase. The only difference is the type of their modulating signal. Analog modulation applies analog signal as is modulating signal, while RDM applies digital signal instead. So in this slide, we can have an overview and comparison over the three modulation techniques in detail. As you can observe, the digital signal is set as 1010, while the carrier signal remains as it is. So let's have a look part by part. When the digital signal is set high, equals to 1, ASK will be high in amplitude, while FSK will be high in frequency. When the digital signal is set as low, the amplitude of ASK will decrease and frequency of FSK will decrease as well. While for PSK, the signal will be shifted 180 degrees at the edge when the digital signal is set from 0 to 1 or 1 to 0. There's another shift keying method known as multi-level shift keying. This technique is applied by representing multiple bits using symbols. In this technique, the symbol is defined as final signal representation before transmitted through the physical medium. For example, amplitude, frequency, and phase. The equation given for the symbol is m equals to 2 power of n, where m is the number of symbol required for n number of bits. Symbol rate or bulk rate is the number of symbol changes that occur per second. This equation is given by bit rate over n, or it can be modified to bit rate over log 2m. So now we'll introduce a new method called quadrature phase shift keying, QPSK. In this method, one symbol represents 2 bits. That means 00, 01, 10, 11 can be represented by a combination of 2 bits, and the phase will be varied from 0 to 360 degrees. For binary PSK, the phase changes from 0 and 180 degrees. For the most common case, the difference is 90 degrees, and QPSK changes from 45 degrees and then 135 degrees to 225 degrees and to 315 degrees. So as you can see in the table beside, they are represented by different symbols for each phase. Relatively, QPSK is better than PSK because of the efficiency in the frequency spectrum. So in this case, QPSK allows signal to carry twice as much information as ordinary PSK using the same bandwidth. I think that's all for Group 6. Thank you and goodbye.